Why hasn't humanity established a permanent presence in space yet, despite significant advancements in technology? It's a question that often crosses our minds as we marvel at our scientific progress. From landing on the moon to sending rovers to Mars and launching telescopes that peer into the distant reaches of the universe, our achievements in space exploration are nothing short of extraordinary. Yet, the dream of living in space remains just that, a dream. This essay delves into the myriad reasons why we haven't colonized space, exploring the technological, economic, physiological, and political challenges that continue to keep us Earth-bound. One of the primary barriers to space colonization is the current state of rocket technology and spacecraft. Despite significant advancements since the Apollo era, sending humans and the necessary infrastructure into space is still a monumental task. Rockets are expensive, complex, and have limitations in terms of payload capacity. Reusable rockets like those developed by SpaceX have begun to reduce costs, but the technology is still evolving. Spacecraft capable of supporting human life for extended periods are another challenge. The International Space Station ISS represents a remarkable achievement in human engineering, but it's essentially a temporary outpost, not a permanent home. Creating spacecraft that can travel vast distances, support life, and protect inhabitants from the harsh environment of space is an immense technological challenge. Sustaining human life in space requires advanced life support systems that can provide air, water, food, and waste management. These systems must be highly reliable and capable of functioning for years, if not decades, without resupply from Earth. While the ISS demonstrated that such systems can work for extended periods, scaling them up for a larger, self-sufficient colony is another matter entirely. Space is a highly radioactive environment. The Earth's magnetic field and atmosphere provide substantial protection from cosmic radiation, but once we leave this protective bubble, we are exposed to dangerous levels of radiation. Prolonged exposure can lead to serious health issues, including cancer. Developing effective shielding or other protective measures against radiation is crucial for long-term space habitation. Space exploration is an incredibly expensive endeavor. The cost of launching, maintaining, and expanding a space colony is astronomical. Even with the advent of reusable rockets, the financial burden remains significant. Governments, private companies, and international coalitions would need to invest trillions of dollars to establish and sustain a permanent human presence in space. The economic return on investment for space colonization is another critical issue. While there are potential benefits, such as mining asteroids for valuable resources or developing new technologies, the immediate returns are not clear. Investors and governments often prioritize short-term gains over long-term, uncertain ventures. This economic reality makes it difficult to secure the necessary funding for ambitious space colonization projects. The human body is not well adapted to the conditions of space. Microgravity, for instance, can cause muscle atrophy, bone density loss, and other health issues.
We've been looking for life on Mars for a long time, and while NASA hasn't found any evidence of life now, we found lots of evidence that Mars could have supported life in the past.
Astronauts on the ISS exercise regularly to mitigate these effects, but a long-term solution for maintaining health in low or zero-gravity environments is still needed. Living in space can also have significant psychological impacts. Isolation, confinement, and the lack of natural environments can lead to mental health issues. The challenges of maintaining social cohesion and ensuring the well-being of space colonists cannot be underestimated.
And the isolation experienced by astronauts is not too dissimilar to what we can all feel here on Earth.
Effective psychological support and the creation of living spaces that promote mental health are essential for any long-term space habitation plan. Space exploration has historically been driven by national interests and competition. The space race between the United States and the Soviet Union during the Cold War is a prime example. While international cooperation has increased, as seen with the ISS, geopolitical tensions can still hinder collaborative efforts. Establishing a permanent presence in space would likely require unprecedented levels of international cooperation and agreements on the use of space resources. The ethics of space colonization also pose significant questions. Issues such as the environmental impact of space activities, the rights of potential future space inhabitants, and the equitable distribution of space resources need to be addressed. Developing a fair and ethical framework for space colonization is crucial for avoiding conflicts and ensuring that the benefits of space exploration are shared by all humanity. Space is an incredibly hostile environment. Extreme temperatures, micrometeoroids, and the vacuum of space all pose significant threats to human life and infrastructure. Developing materials and technologies that can withstand these harsh conditions is an ongoing challenge. The environment of potential habitats, such as the Moon or Mars, also presents unique difficulties, including dust storms on Mars and the lack of atmosphere on the Moon. Establishing a self-sufficient colony in space requires a robust logistical framework. This includes the transportation of materials, construction of habitats, and ongoing maintenance and resupply missions. The complexity of building and maintaining infrastructure in space is immense, and any failure in the supply chain could have catastrophic consequences for the inhabitants. Despite the challenges, significant progress is being made. Advances in robotics, artificial intelligence, and biotechnology hold promise for overcoming many of the current barriers to space colonization. Innovations in propulsion technology, such as nuclear thermal propulsion or ion drives, could drastically reduce travel times and costs. Continued investment in research and development is crucial for turning the dream of living in space into reality. New economic models are emerging that could support space colonization. Public-private partnerships such as those between NASA and SpaceX are a step in the right direction. The potential for space tourism, asteroid mining, and other commercial ventures could provide the financial incentives needed to drive investment in space infrastructure. Establishing clear economic pathways and demonstrating tangible returns on investment will be key to securing the necessary funding. Building a permanent human presence in space will require unprecedented levels of international cooperation. Establishing international treaties and agreements on the use of space resources, the protection of space environments, and the governance of space colonies will be essential. Collaborative efforts, such as the Artemis Accords and the International Space Station, provide a framework for future cooperation. Ensuring the health and safety of space colonists is paramount. Ongoing research into the effects of microgravity, radiation protection, and life support systems will be crucial. Developing new technologies and protocols to protect and support human life in space must remain a priority. Addressing the psychological aspects of long-term space habitation, including mental health support and the design of living environments, is also critical. Ethical considerations must be at the forefront of space colonization efforts. Developing a fair and equitable framework for the use of space resources, protecting the rights of space inhabitants, and minimizing the environmental impact of space activities are essential. Engaging with diverse stakeholders, including scientists, policymakers, and the public, will be crucial for addressing these complex issues. While the dream of living in space remains elusive, the future holds immense promise. The challenges are significant, but so are the potential rewards. With continued technological innovation, economic investment, international cooperation, and a commitment to ethical and sustainable practices, humanity can overcome the barriers to space colonization. The journey will be long and difficult, but the ultimate goal, establishing a permanent human presence in space, is within our reach. The future of humanity in space is not a question of if, but when.